All right, this is a graph of a parabola, and we're going to look at some of the important points that you can find that you can use to graph it, okay? So it crosses the x-axis there and there, where y equals 0. It crosses the y-axis right here, where x is 0. And it has a turning point right there. And it even has a line of symmetry, which is the line that it is symmetrical about that line. So that is the line of symmetry. Oh, my writing is not very good today. Line of symmetry. So you've got a y-intercept, you've got two x-intercepts possibly, and a turning point. You don't always have two x-intercepts though, because let me quickly show you that. This particular parabola has 0 x-intercepts, and this one has exactly 1 x-intercept, assuming that was touching properly. I am going to start by showing you how to find the y-intercept. All right, the y-intercept is the place on the graph where x is 0, where it crosses the y-axis, this spot right here, okay? For the parabola or the graph to cross the y-axis, x must be 0. So it crosses, so the y-intercept is where x equals 0. So here is one of the questions from the worksheets that I gave you. And we are going to find out the y-intercept by setting the x to be 0. 0 is the number that goes into our function machine. So we're going to rewrite this with like this. Y equals 0 plus 3 times, the brackets round because we're multiplying, 0 plus 4, and that is 3 times 4, which is 12. That particular function has a y-intercept of 12. It crosses the y-axis at y equals 12. Let me do another one. All right, exactly the same thing. We're going to let x equal 0. So y equals 0 squared is 0, plus 2 lots of 0, plus 3. So y equals 3. In fact, if you have the equation in this form, the c number, this number by itself that you add on the end, is always the y-intercept. So it's nice to have the equation in that form because then you can always find the y-intercept. Oh, here's another one. One more. Y equals 3x lots of x plus 1. All right. X is 0. Y equals 3 zeros is 0 times, or it doesn't matter what it's times because, 0 times 1 in this case, equals 0. Y-intercept is 0. Okay? Let x equal 0, you will find the y-intercept. That is all for y-intercepts. All right, finding x-intercepts is a little bit harder because there are sometimes 2 of them, sometimes 1, sometimes none. Most of the time you're going to find there's 2. So for the graph to cross the x-axis, it's in this place here where y equals 0. So we let y equal 0, which is what I've done here in this equation. So where y equals 0, for y to equal 0, one of the things we're multiplying together must be 0. So we're multiplying 2 things together in this equation. we're multiplying this x. So x could be 0 because 0 times a bracket is 0. Could be x equals 0. Or the bracket could be equal to 0. So we're going to go for x take 1 to equal 0. What is the possible value of x? Well, I know that 1 take 1 is 0. Or, you know what, I can do algebra here. I can add 1 to each side to get rid of the 1. And I can go x equals 1. So if x was equal to 1, y would be 0. 1 take 1 is 0 times anything in 0, right? So these are the 2 points on the graph where that parabola crosses the x-axis. It crosses here and it crosses here, and it might look a little bit like that, maybe. We don't know with just the 2 x-intercepts. So that's one. Now, when you see this word solve, we're asking you to find the x-intercepts. Let me get another example for you. All right, here is another example. For this function to be equal to 0, as that is for y to equal 0, so that we are finding out where we're crossing the x-axis, one of these brackets, either this one or this one, must be 0. Okay, for x take 3 to equal 0, we'll do some algebra because that's always nice. We're going to add 3 to each side because that gives us just x over here and 3 over here. Right, so if x is 3, that is one of the places where it crosses the x-axis. And we'll do the same thing over here. X take 4, for x take 4 to equal 0, we must add 4 to each side to find out the value of x. And we're going to go x equals 0 plus 4, which is 4. These are the x-intercepts. These are the places where it crosses the x-axis. Also, I was just thinking, if you're looking at that equation saying, that doesn't look like it's quadratic, it doesn't have x squared in it, I'm going to show you that it does, because this is one of the things you needed to do. You needed to expand the brackets out, right? So we're multiplying these 2 brackets by each other, so we multiply x by x, and we get x squared. We multiply x by minus 4, and we get minus 4x. Then we go to the minus 3 here, and we multiply it by x, and we get minus 3x. And then we multiply minus 3 by minus 4, and we get 12. And then we collect our like terms here, our x's, and we end up with a simplified quadratic expression, quadratic equation, function, whatever you want to call it. X squared take 7x plus 12. Okay? You need to be able to move fluently between these 2 forms of the same equation. From this one, you can find the y-intercept. From this one, you can find the x-intercepts. So you need to be able to expand and factorize. Let me find another example for you. Yeah. Sometimes you see it in this kind of format. So we can do exactly the same thing. We can expand and simplify. So x plus 3 squared looks like this. And then we take 16. So let's expand the brackets because that's the first thing always with your BIMDAS. Here we go, x squared. Plus 3x. Plus 3x. Plus 9. And don't forget to take away 16 at the end. Okay? Now, we collect all the like terms. We're going to round up all the x's, and we're also going to simplify this part as well. So we're going to end up with x squared. We've got 6 x's altogether. And if I add 9 and take 16, I have got a net minus 7. And there's our equation. And we can find the y-intercept from that. The y-intercept is minus 7. If we want to find the x-intercept, we'll have to factorize it. So let's have a go. Let's factorize this. We've got x squared, which means we've got an x in each bracket. We are looking for two numbers to go in the brackets that multiply to get minus 7 and that add to get 6. So, first step is to list the factors of 7. 7's a prime number. Those are the only factors of 7. We're multiplying to get minus 7, which means one of them is going to be a negative number. So our options are negative 7 and 1, 7 and negative 1. And the sum of these is 6. So those are my numbers. X plus 7, x take 1. If you expand them out, you expand those, you will get this. Factorizing, expanding. Okay, you find your x-intercept from this format, you find your y-intercept from that format. Let me find the x-intercepts of this particular function. Let's see, for x plus 7, bracket 2 equals 0, x must be minus 7. So there is 1. For this bracket to be equal to 0, x must be 1. So now we know where it crosses the x-axis, where it crosses the y-axis, and then you can use those to draw the parabola. So where x equals minus 7, so that is the point minus 7, 0. This one is the point 1, 0. And this one is the point 0, minus 7. Okay? X-intercepts and y-intercepts. And what else did we have to do? Turning points. Yeah, let's do more. Let's do more. All right, we're going to factorize this. We can see that the C number, the number by itself, is 0. It's like we had a plus 0 on the end. It's just not written there. But a way that we can factorize this is I can see a common factor that is in 2x squared and is also in minus 6x, and that is 2x. I'm going to pull a factor of 2x out of each of those terms, and I'm going to be left with, well, this first one is 2x times x, and this second one is 2x times minus 3. And now that one's factorized. Okay, so the C could be 0. The B could also be 0. I have an example here. Here it is, x squared, take 49. So we are looking for, we're going to have an x here and an x here, and we're looking for two numbers that multiply to get minus 49 and that add to get 0. So they're the same number, 1 plus and 1 minus, so that they add to get 0. What's the square root of 49? 7. Let's try this, x plus 7, x minus 7. We would end up with x squared, take away 7x plus 7x, take 49, which is the same as saying x squared, take 49. So you can factorize them by taking out a common factor like you did over here, especially if there's this nice complicated number in front of the x. Let's stop there, and then I'll show you how to do the turning point. It's super easy next video.